Kingsa.com.
Howdy, 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 and welcome to lesson on PHP functions. First thing we got to think about in functions is we're going to take a large problem and break it into smaller problems. We first learned this in math class. When you're presented with a large algebra problem, you need to break it into smaller problems, solve the smaller problems to solve the bigger problems. Another computer example of this would be a laptop versus a desktop. I'm doing this video right now on a laptop. On any laptop, if the keyboard goes bad, you might as well replace the whole laptop, because as one large piece, you have to rip apart the whole laptop to replace the keyboard. Well, think about the keyboard on your desktop. It's a simple separate piece. If something goes wrong with your keyboard, you simply replace the keyboard. $10, you're done. So when things are built in one large contiguous piece, like a laptop, they're much harder to work on, they're much harder to maintain than when the problem is broken up into smaller pieces. So let's get started here. We'll start with a generic PHP function, and look what it happens. Again, I want you to focus on the red underlines. When I underline something in red, that's what I'm talking about. So we're going to break our large problems into smaller problems. That's what a PHP function does. By the way, if you've programmed in another language and you know what a subroutine is, or a subprogram, or a method, you know what a PHP function is. It's a small piece of code that you can break into its own piece and execute anytime you want. Outlined in red here, a box that contains an entire PHP function. And function is the proper term in PHP because we have to use the keyword function in order to create a new one. Like I say, this is very generic. That's why I called it any function. This is the entire function, from the word function to this closed curly brace down here. Now, in order to understand functions, I'm going to go through a set of terms, and I'm going to highlight both the term down below and underline that part of the code. So we're going to start with the function header. The function headers are easy to spot in PHP. They always start with the keyword function. This line of code from function to the open curly brace is known as a header. It's sort of the declaration of the function. It names what the function is going to be. It lists any parameters. This is the header to the function. The body of the function is the code that will execute when we call the function. This is the executable PHP code that will run every time this function is invoked. The call to the function is at any point in the code we can tell it to go execute this function. So somewhere in this code we're going to run any function, and this is the call to the function. Now, quite often students confuse the header and the call to the function. In PHP, you shouldn't confuse the header to the call to the function. The header always has the keyword function in it. That will always be the header. The call does not have the keyword function in it. The argument to a function. An argument is a piece of information that we send to the function. The argument, in this case 27, is going to be sent to the function and be input to the function. A parameter to the function. The argument 27 gets assigned to this variable $parm1. The parameter is input to the function. The function needs some input in order to do its job. You send it as a parameter. Return type. Functions can send things back. They don't have to, but they can send things back to the user. In this case, the return type is an int. Since we're sending a 0 back, we're sending a numeric integer value back. The return type is the type of variable or piece of data that gets sent back from the function. Now, as you should know, the type and the value are different. The value here is 0. The type is int, the value is 0. In this case, I hard-coded a 0 because this is meant to be a very simple generic function. But this function could return a 14 or a -6 or a 27. The type is int. The value in this case is 0. Functions should be fairly consistent in what they send back. You want a function to send back an integer every time. You don't want it mixing up strings and integers and floats. You want the functions to be very consistent so the user that's calling the function knows what they're getting back, at least the type of what they're getting back. Those are the sort of terms you need to do or learn to understand what a function is, let's go ahead and trace some code and see how a function works. This is the call to the function. As usual, we'll execute the right side of the equal sign first, and we will invoke the function, any function, and we'll pass it the argument 27. The argument 27 will be assigned to the parameter of the function. Essentially, we are assigning 27 to $parm1. And at this point, the code will jump and execute the function. The code that's in the body of the function will execute, and as it executes, it will eventually finish. When it finishes, it will execute the return statement, and the return statement is exactly as the name implies. It will return back to the caller. So the code called the function, executed the code, and is now returning back to the calling code. Now I pointed to that equal sign because see that return 0? That return 0 has to go somewhere. It's going to go to whatever is being assigned to any function. So you can see it a little clearer in this slide, right? The 0 that came back is what is going to be assigned to $return value. That's why I put the equal 0 over here. The 0 that came back from the function is going to be assigned to return value. And you can see over here on the right in the red box that a 0 showed up as return value. Again, this is very generic. I called a function, I sent it some input, 27. It sent me back some output, 0, and I took that output and assigned it to my local variable, $return value. There you have it. That's a generic function. Let's go ahead and do an example with some real code. Now there's a second reason for writing functions. Number one was we want to break our large problems into smaller pieces. We never want to write a program as one blob of 1,000 lines of code. We want to take that code and break it up into small, easily maintainable pieces. That's reason number one for writing a function. Reason number two for writing a function is we want to write once and use many times. Well, what does that mean? Write once, use many times. Well, let's say I have a block of code that I want to execute 10, 20, 30 times in the code. Well, I don't want to copy and paste the same code 30 times. That's a maintenance nightmare. What I want to do is take that code that I want to execute 30 different times, put it in its own function. I want to write the code once in a function, and then every time I need to use that code, call it from my program. I want to write the code once and use it many times. Now, nowhere is this more evident than in screen update. If we're writing a video game, we're going to display some information on the screen. Now, we've got a choice here. We can display information on the screen from dozens and dozens and dozens of different places in our code. And whenever we want to change the screen, we got to go change dozens of places in our code. Or we can write one function, one spot in the code that updates the screen, that displays some information that we want on the screen. We write it once in one spot, and then whenever we want to change that information, we call the function to change the screen. Then when it comes time to update the screen, what do? We change that one piece of code, and all the different places we called it get updated automatically. We're sort of funneling screen updates to one spot in the code so we can update it, so we can change it without having to rewrite all our code. Write once, use many times is an important concept of why we break our code up into smaller functions rather than writing code as one big blob. Here's more of a real function. Let's write a function to update the screen. Let's just say the information we want to show to the user is the score and health. Right? That's what video games do. As you get into a level and you pick up things and you earn points, your score goes up. The health has to do with whether you survive or don't survive. Do things right, your health score could go up, and we want to tell the user their health score goes up. If you take damage, if things are attacking you and you take damage and your health score is down, we need to update the screen and show the user your health score is going down. In the end, we want our scores to go up and we want our health scores to stay high. This is what we're going to display to the user, what their score and health is. And what I'm going to do is isolate all that code to update the screen into this one function. Now, what's the function header? It's obviously this line with the word function on it. The header in PHP is always the line with the word function on it. What's the function body? It's the executable code of the function. It's the print statement. That's the body of the statement. And where's the function call? The function calls outside of this box. I call this function several times, 1, 2, 3 times down here. There's 3 function calls here. And again, that means I don't have to update 3 different places in the code. If I want to change how this updates the screen, I change the one function and all 3 of these places update. So let's trace this code and see what happens. Here's our first call to update screen. This is obviously the call to the function. And we are going to pass these arguments to the parameters. Now I drew the arrows here to show you that 0, the first argument, gets assigned to the parameter score2. And 100, the second argument, gets assigned to parameter health2. And you can see over here on the right in the red box that score2 now has the value 0 and health2 has the value 100. This assignment is done automatically under the covers. The first argument always gets assigned to the first parameter, the second assigned to the second parameter, and so on down the line. What we've done is we've transferred the arguments, the values in the arguments, to the parameters, and it's time to execute the function. Inside the code here, we're going to use a simple print statement and update the screen. We're going to notify the user the score has the value of $score2, and the health has the value of $health2. Now you can see the parameter values 0 and 100 is what shows up down here on our output. Here's my score 0, there's my health of 100. That might be your initial start of the game, right? You have no points at the beginning of the level and you have full health points, 100. As the game progresses, you expect those scores and health values to change, and after we update the screen, the function will return back to the line of code after the call to update screen. So what we were is we were at update screen, we went and executed the code. When it's done, it's time to come back. When it's time to come back, we'll execute the line of code after the original call to update screen. Update a few variables here. We'll set score to 20 and we'll set health to 72. Now what I want to stress here, and I did it with different names here, is score and health are separate variables from score 2 and health 2. In fact, I drew a red X around score 2 and health 2. These parameters only exist while this function is running. When this function is done, those parameters go away. So out here in this code, these are different variables. Score equals 20, health equals 72. Those are the values in these 2 variables at this point in time. Now after that line of code executes, we'll call update screen again. This time, however, instead of sending hard-coded values, 0 and 100, I'm going to send the variables score and health. Once again, the first argument, $score, is sent to score2. The 20 here on the right gets sent to the parameter score2 over here. The value in $health, 72, gets sent as the argument to $health2. Again, under the covers, this assignment is automatic. But notice here how the arguments down below here were sent to the parameters up above with the red box around it. That is how it works. More often than not, you'll be sending a parameter as an argument to a function rather than a hard-coded value. As this game progresses, the score and the health values are going to be changing all the time. You need to keep track of that in their own variables. When it comes time to update the screen, send them as parameters to update screen. We'll call the function, we'll pass the arguments and assign it to the parameters, and now it's time to execute the function again. This time, when the print statement outputs, you'll see that the values of the parameters get output to the screen. The 20 in score 2 shows up on the output. The 72 in health 2 shows up on the output. Now are you starting to see it? Dozens and dozens of places in the code, I can tell it update the screen with these values. When it's done updating the screen, of course, the function will return. When the function returns, it will return to the line of code after the last call to update screen. And in this call, we'll call it again and we'll adjust the arguments slightly. All update screen cares about is you send it two numbers as parameters. Whether those numbers come as hard coded values like 0 in the original call, or the value of a variable like $score in the second call, or the value of a math equation $score plus 10, it doesn't matter. As long as this is a number when it gets to update screen, nobody cares. Where that number comes from doesn't matter. So what I'm going to do is a little math. $score plus 10. Score contains a 20. I'm going to add 10 to it, make it a 30, pass it to the parameter score 2, and you can see that a 30 showed up here in the red box. There's a 30 in the variable score 2, the result of this addition. For the second argument, I'm going to do $health minus 4. Well, health is 72. Subtract 4, you get a 68, and you can see over here on the right, in the red box, a 68 has shown up. Are you getting the picture here? I can send anything I want to update screen as an argument, as long as it's a number that I can display on the screen. The input is expected to be two numbers. How those numbers are generated, hard-coded values, variables, or the result of a math equation, doesn't matter to update screen. Here's my new numbers, score 2 and health 2, and on the output you can see it's going to output 30 because that was in a parameter, and 68, that was in the health 2 parameter. Many places in the code I can tell it to update the screen, and every time it will take the value of the parameter and put it on the screen. Now, why is this a big deal, you say? Well, let's see what we can do with this now. Update screen will return after the code and continue executing. Now, here's what I was talking about, the ability to change the code without rewriting a lot of code. Let's say we want to do a Spanish language version of our game. Would you rather go to dozens and dozens of places in the code and adjust the language in dozens of places? Or would you rather go to this one place, update screen, and change it? So I went on to Google Language and popped in the word score and the word health, and I found out the Spanish words for score and health, and I substituted there. Now what happens here is I have to change this one line of code inside an update screen, not 100 lines of code everywhere else. I don't have to change the code here and here and here. I'm going to isolate my code to display to the screen in one place. So if I ever update or change how I output to the screen, I do it in one place and all the calls automatically output. This call to update screen right here will output in Spanish. This call to update screen will output in Spanish. This call. So imagine if I'd called update screen 100 different places. That's 100 different places that all changed to Spanish. Now, if that wasn't enough, let's do a French language version. Once again, I went on to Google Language. I hope these are the proper words. Have no idea. In Google Language, it said les scores and santé were the words for French. So I switched to French, and now I'm building a French language version of my game. Once again, I changed this one place where I'm updating the screen, and boom, it changes everywhere. If I'd called update score from 100 different places in the code, all 100 places would output in French, not Spanish, not English. We want to write once and use many times. This is an important concept of why we use functions. The second reason we do functions is to break large problems into smaller problems. Let's take a closer look at parameters and return values. Remember, parameters are input to a function, and return values are the output of a function. Quite often, in order for a function to do its job, it's going to need some input, and when it's completed its job, it needs to tell the caller what happened. It needs output. Parameters are the input. In this case, $arm and $damage are the parameters to calc damage. Now, let me explain calc damage here. Often in a video game, players are allowed to acquire armor, and armor should protect them. If you get hit by something and you're wearing a lot of armor, it should protect you. If you get hit by something and you're not wearing a lot of armor, you should take that full damage. So that's what this code is doing. That's what this function is trying to decide. How much damage do I inflict on the user when they get hit based on the amount of the armor? Now, since your armor value is always going up and down, and since your damage value is always going up and down, you need to adjust for both factors. That's why we're sending input to this calc damage, which is short for calculated damage function, telling it what is your current value of your armor, what is the damage value that this hit should take. Based on those inputs, how much armor you have and how much damage you would normally take, we're going to calculate a return value. Once again, the idea here is if you have a lot of armor, you shouldn't take a lot of damage, and that's what the return value will tell you. If you don't have a lot of armor, you should take the damage, and that's what the return value will do. Based on those two inputs, it will calculate the amount of damage that should occur and send that back as a return value or as output from this function. Let's see how this works by running it with some initial values. I'm going to set up some variables over here on the right and just assign them values. Health has 93, armor is currently at 55, and the damage value for whatever just hit us is going to be an 8.0. Let's call calc damage, and based on these current factors, decide how much damage should occur to the user when they get hit. We'll send armor and damage as arguments to calc damage, and you can see they show up in the parameters. Arm is 55 and damage is 8.0. I made the names different in the first parameter just to show you they don't have to match. It's called armor as an argument. It gets assigned to the parameter arm there. But the second argument, damage, just went to damage. What I need to stress here is parameters are what we call local variables. This parameter is a copy. You'll notice there's a dollar damage up here as a parameter. There's a dollar damage that was sent here. That's not by accident. These are two different variables. I want to illustrate that fact that parameters are what we call local variables. They're copies of what you send. Now we have our input, 55 and 8.0. We're going to look at that input and see what we should do. Our current value in ARM is 55. 55 is less than 10 is a false statement. If ARM was less than 10, we had very little armor. We should take full damage. But 55 is greater than 10, so we shouldn't take full damage. We do have some armor. So what's going to happen here is we'll go to the second if. Notice how when this first if was false, it skipped to the second if. Now on the second if statement, 55 less than 6 is a true statement. We have a medium amount of armor. We have some armor. We don't have full armor, but we have some armor on us. So what we've decided to do as a true statement is we're going to come in here and execute this return statement. And the return statement says if I have roughly medium or half my armor that I could have, I should only take half damage. Damage value of 8 should be cut in half. And when we execute damage times 0.05, we'll get a 4.0. Does that make sense? Let's say your maximum armor amount is 100 and you have half of that, 50. You should take half damage when you get hit. So we'll calculate that half damage as 4. Send it back as an output as a return value from the function. When it comes back, it will be 4. What would have caused 8 points of damage will only cause 4 points of damage. The more armor you have, the less damage you should take. So our original value in health, which is 93, gets subtracted by 4 because we took a hit with half armor and becomes an 89. What happens to that 89? Well, it turns around and gets assigned to the health variable. You can see the health variable over here on the right in the red box has updated to 89. Are you seeing what this function is doing? If I have no armor and I take a shot that would cause 8 points of damage, it should cause 8 points of damage. If I have medium armor, it should take half damage. If I have full armor, it should take no damage. Let's see that. Let's run it again with new values in the variables. This time our health is still 89. We'll keep that in there just so you can see how as the game progresses, our health damage for various shots will vary depending on the amount of armor. But on this next shot, we've acquired more armor. We have a much higher score in our armor, 92. We shouldn't take a whole lot of damage. We have almost full thing. So even though we're getting a shot here that would normally cause 10 points of damage, we need to adjust that. So we'll call the function and we'll say at the time that this hit occurred, we'll send you an armor value of 92, and you can see that it showed up in the parameters 92. Remember, this is a copy of this variable. So the 92 got copied to arm. And we have a damage value for this shot that should be at 10.0. Full damage would subtract 10 from our health score. So we'll send this as a parameter damage, and you can see the 10 showed up there. And again, this is a copy of the damage variable. Now calc damage is going to answer a simple question. If I have 92 points of armor and take a shot that would normally cause 10 points of damage, what is the true damage that it should cause based on my armor? 92 less than 10 is a very, very false statement. And you can see by the arrow here, if this statement is false, it will skip down to the next if statement. 92 less than 60 is still a false statement. Because this if statement is false, you can see by the arrow, it'll skip down to the next if statement. 92 less than 95 is a true statement. 92 less than 95 will cause the if statement to execute the code inside the if block. And you can see the arrow is showing, hey, I found my current level of armor. 92 out of 100 is a lot of armor. I have almost full armor, not quite full armor, but I have almost full armor. So what I'm going to do is take 10% damage. If my normal damage to this shot would be a 10, but I have very high armor, I'm going to take a 10% hit. I'm going to damage times 0.01, which is 10%. I'm going to reduce that damage score from a 10 to a 1. Makes sense. You got 92 points of armor. You shouldn't take a lot of damage when you get hit. That 1 is going to be sent back as output. Remember, the parameters are input. The return value is output. I'm going to send an output of 1, telling the code at that point for your armor and that amount of damage, this is what you subtract from the health. Current 89 gets the reduced damage score of 1 and comes out as an 88. What did we do with that 88? We update our health variable. You can see that 88 that was calculated is now showing up in the red box on the right. That makes perfect sense to me. If I'm wearing a lot of armor, I should take very little damage when I get hit. That's it. Now I could call this several more times. You could see if I had 100 points of armor, this would be false, this would be false, and it would return no damage. If I'm at full armor and I take a hit, I should take no damage. This is simple code, it's simple logic. When you put it in a method like this though, it allows great flexibility. Anywhere in the code that I get hit and I need to calculate a new health value, I can do that calculation once up here in calc damage. There'd be hundreds of spots in a video game where your player is being hit and you need to calculate how much damage or how much to subtract from the health value. If you do that calculation in 100 spots and you want to adjust it, you got to change 100 spots. But if you always calculate damage in one small function and you want to adjust how the game works and how much damage you get, you adjust that one spot, it updates all the calls automatically. Parameters and return values make our functions much more flexible and usable, and it allows us to maintain our code much better. Global versus local variables. The variables you declare outside the function are different than the variables you declare inside the function. The variables you declare outside of functions are what's known as global variables. The variables you declare inside of a function are known as local variables. Let's take a look at the difference between global and local variables. First up, here at the top, declared outside the function, I'm going to create a couple of variables, x position, y position, or x pos, y pos. This is the xy coordinate of my character on the screen. These are what's called global variables. Why are they global? First and foremost, they're declared outside the function. They're not inside move x, they're not inside move y, they're declared outside the function. Technically, the way PHP works, these don't have to be at the top of your code. But trust me, I like to put them at the top of the code. That way I can look at the top of the code and see what my global variables are. It's not a requirement, but for this class, make sure you put your global variables at the top of the code. We'll initialize those both with 0, so you can see here over on the right, my global variables have 0 and 0 in them. What's a local variable? A local variable is one that's declared or created inside of a function. If you look at the xdiff parameter to move x, that's part of move x. So technically this is inside of move x. If you look at xnew here, that's inside of move x. So it's local to move x. So these two variables, xdiff and xnew, are local to move x. They belong to the move x function. Notice in move y difference is a parameter. It's part of move y. Y new is inside of move y. It is a local variable. Is that pretty clear? Globals are outside the functions. Locals are inside the function. That's the difference. It makes a big difference on how those variables are used. So let's run the methods with some initial values in the variables. So we're going to be running move x, and the time that move x runs, we're going to have an x position of 5 and a y position of 580. So somebody has updated that code, right? As your character moves around the screen, x and y position are moving all over the place. They're constantly changing. So at the time we called move x, that's what was in those values. Here's the call to move x, and we're going to say move the x differential minus 8. My argument of minus 8 is going to be passed to move x, and you can see the minus 8 showed up here on the right. There's a very important reason I drew two separate boxes over here. My local memory, or my local variables, is different space than my global variables. So my global variables are occupying this space, and my local variables are occupying this space. Currently, when move x is executed and minus 8 is sent as the argument, my local variable xdiff gets sent to minus 8. Once inside the function, here's a new line of code. In the red box is global $x position. What that is saying is for this function, we want to use that global variable declared up at the top. Probably should have drawn a line from here over to here to say this line of code is saying use that variable over there. Normally inside of a function, it would not try to access a global variable. In PHP, which is different than other languages, you have to explicitly tell the function, I would like to access the global variable. In this particular case, it is saying I would like to access the global x position variable. When I do this line of code, $x position, it will go get the global value of x position, which is 5. It will then use the local value of x difference, which is minus 8, and it will calculate the value of minus 3. This equation is using one global variable, x position, one local variable, x difference, and calculating a minus 3. One of the reasons it's doing that is it wants to figure out whether this is a good move or not. A video game has a coordinate, an x and a y axis. If you're in that x and y coordinate, you can show the character. But what happens if the player tries to move off the screen? Well, many games won't allow the character to move off the screen. And what MoveX is going to do here is calculate the new position and then decide if it's a good position. If it's good, it will accept the new position. If it's bad, it will reject the new position. I'm going to set X new, which is the new position that we want to move to, as a minus 3. And you can see when this equal statement executes, a minus 3 shows up in X new. Why is that important? Once again, We're writing, let's say, a two-dimensional game, and we do not want that character moving off the screen. So when they move to the left side of the screen, we want them to stop. When they move to the right side of the window, we want them to stop. What MoveX is going to do is make sure that the character never moves off the screen. It's looking at, is x new greater than or equal to 0? Well, 0 is the far left of the window. 0, anything past 0 into the negative range means you're drawing the character off the left edge of the window. We don't want that. If x new is a bad value, which it is, -3, we want to return a false. And as a false, we are going to exit the function instead of adjusting x position. What this is doing is saying, hey, even if they hold down the mouse button, even if they move the left arrow key over all the way to the edge of the screen, I will stop this character from moving off the edge of the screen. It may seem that we did a whole lot of stuff for no reason at all because we never updated X position, but it's an important thing. If you don't want your character leaving the screen, move X is going to make sure that it doesn't go off the screen. So since this first one was false, the whole thing was false, move X decided not to move the character. I'm sure you've played a video game before. I'm sure you've played a video game where the character stays on the screen all the time. Well, that's how it does it. It makes sure that it doesn't go off the screen and refuses to update X position. Notice how X position, which started at 5, stays 5. That keeps the character on the screen. When MoveX was done, look at my little message here. Locals deleted. Everything went away. That is a big difference between global and local variables. Global variables, which are declared outside the function, stick around. No matter how many functions you call, the global variables stick around. Local variables are owned and operated by the function. They don't exist before the function is called, and they get deleted after the function runs. So the xdiff variable that was created disappeared. The xnew variable that was created disappeared. Local variables get deleted when the function is done. Globals do not. Let's try it again. Later on in the game, we're going to call move y. Somebody hit the up arrow or the down arrow and says, I want to move my character on the y-axis. Currently, we have an x position of 5 and a y position of 580. We're telling it, I want to move the character on the y-axis this time. We'll call move y, and we'll say adjust it by 5 this time. We'll pass a 5 as the argument to move y. And you can see that the parameter ydiff automatically gets that 5 set to it. We haven't changed the ynew variable yet, so there's nothing to show in ynew yet. And we'll say, let's execute y position plus y difference. Telling the code to move the character on the y-axis by 5 pixels or 5 positions. We'll grab y position, our global variable. Now notice this red box around the word global. It says I want to use the global y position variable. Once again in PHP, you have to declare inside the function whether you're going to access a global variable. And in this case, we most definitely are. Also notice how y position is in bold font. I wanted my globals to stand out, so I made them global at the top. And everywhere I try to access a global in the function, I make it in a nice, thick, dark, bold font. Be clear here. I'm saying access a global. Y position is a global here. Y position is a global here. That's why I kind of highlight that it's a global variable, because global variables are different than local variables. I access the 580 out of the global space. I get the 5 from the parameter y different, and I calculate a new y-axis position of 585. The equal assigns the 585 that I calculated into the ynew variable, and something finally shows up in my local variable ynew. Now what this is saying is I want the new y position to be 585. The next question to ask yourself, is that a good value? Remember, I do not want the character to leave the screen. Apparently, I'm running this in an 800 by 600 window where I have 0 to 800 on the x-axis and 0 to 600 on the y-axis, and I want to make sure I don't go off the edge of the screen. So in this case, I'm going to make sure, is ynew greater than 0? Well, it is. 585 is clearly greater than 0, so I have no problem with the top of the screen. Is y new less than 600? 585 is less than 600. Guess what? That is true too. This means I haven't gone off the top of the screen. This means I haven't gone off the bottom of the screen. This is a perfectly valid new position on the y-axis. In that case, since this if statement is true, I'm going to execute the code. Basically, what move y is saying is I agree with that move. That move will not take my character off the edge of the screen. Let's go ahead and update the global variable. Once again, because of this keyword global up here, this is accessing the global variable. And this new value that I've calculated gets updated. My 580 just changed to 585. Since the global variable changed, my character position will change on the screen. Also notice when this function is done, it will leave the code here and move past the call to move y. And the next time the screen updates, the next time I draw the player, it will be at the new position of x is 5, y is 585. See what move x and move y are doing? They're making sure our characters don't move off the screen. When a move is legal and keeps the character on the screen, it will update the global variable. When it's illegal, when it moves it off the screen, it will not update the global variable. So our player will stop at the edge of the screen. Also notice how my local variables disappeared. Remember, local variables get created when the function is called. They get deleted when the function is done. So local variables are just temporary storage. They exist as the function is running and poof, they go away when the function is done. But globals stick around. So the next time I update the screen, I'll put my player at my new position. There's three major differences between global variables and local variables, and let's look at those three differences now. Number one, globals are declared outside of a function, hopefully at the top. Locals are declared inside the function. The globals are declared outside the function, hopefully at the top. That's where x position and y position are declared up here. Locals are declared inside of a functions, and parameters are very much local variables. So ydiff and ynew are inside move y, they are local variables. X position, y position are outside the functions, they are global variables. The second major difference is what's called the scope. The second major difference is the global scope for all functions. Locals means variables are good only in their own functions. The global variables x position and y position may be used in any function, move x, move y, etc., but you must use this keyword global. So anywhere I use this keyword global, I can access it. If I wrote 30 functions and I put this global x position at the top of all 30 functions, then all 30 functions can use these variables. Local variables are though quite different. Local variables x new, xdiff, ynew, ydiff are only good in movex. The local function owns these variables. So movex owns xdiff and xnew. I can't use xdiff and xnew here. Even if I had variables with the same name, they wouldn't be the same variables. Every function gets its own copy of its local variables. This is a very important thing to understand. It's called the scope. Global variables are accessible in all the functions. Local variables are accessible only when their function is running. Finally, the third difference between global and local variables is what we call the lifetime. The lifetime of a global variable is while the program is running. However, locals are created and deleted on demand. Well, what does that mean? It means if I have global variables x and y position, they are created when the program first runs, and they will exist and not be deleted until the program completely ends. If my program runs for an hour, these global variables will exist for an hour. As long as the program is running, the lifetime of these variables will be good. It will exist. Locals, however, are very different. Locals are created as soon as the function runs. They're deleted when the function ends. Locals are created and deleted on demand. If movex never runs, xdiff and xnew never exist. If movex runs for just a millionth of a second, then these two variables, xdiff and xnew, only exist for a millionth of a second. You got to think of global variables as being sticky. They stick around, they don't go away. You got to think of local variables as disposable. They don't exist until you run the function and they poof disappear like magic as soon as the function is done. Those are the three differences: where you declare them, their scope, and their lifetime. A good understanding of global and local variables will allow you to write very flexible, very updated code. You don't want to overuse globals. The thing about globals is if I have 100 of them, it's very difficult to manage. You only want to use very, very important things as global variables. Now, X and Y positions are a perfect example. In a 2D game where my character is moving around the screen, there are no more important variables than the X and Y position where I draw that character. It's a perfect candidate for a global variable. But if I have 100 of them, it's too hard to manage. Use global variables, but use them sparingly. Only use them for the most important information. All right, let's look at an important thing when it comes to functions and passing parameters, and it's something called pass by value, which essentially says let's make a copy of the parameter, sometimes called call by value, but it basically says a parameter is a copy of the variable that was passed to the function. Now, to see how that works, let's set up a global variable called money and start the player with $20 in their global variable money. Again, global variables are only for the most important variables, and if the object of this game is to accumulate money so you can buy things, then certainly that is an important variable. We'll make that one global. Let's execute a simple print statement. Comes from the main page or another function, but we're going to print what money is before we call the function. And since the variable money contains a 20, you can see on the output, money before calling the function is a 20. Call the function display money and pass money as a parameter. Clearly, money is its own global variable containing a 20. Watch what happens when money gets passed to the parameter $cash. $cash is a local variable. It gets a copy of the 20. That's what I mean by pass by value is a copy. The variable cash has a copy of the 20 that was in money. Cash is not the same variable as money. It is a different variable that contains the same value as money. And of course, as a parameter, it has the same value. So when I print cash on hand inside the function, I'm printing the copy. Cash is a copy of this 20. So cash on hand is a 20. Now here's what's important to understand about parameters. Let's say I change that parameter. Let's say I say cash equals 0. Don't know why I did it, but I'm zeroing out this guy's bank account. I'm changing the copy, not the original. If you look at that cash equals 0, look at this bottom arrow. It's zeroing out my local variable cash. It's changing the parameter to 20. What did not change? What didn't change is this upper arrow. The variable money I set as a parameter when I originally called display money doesn't change at all. This is an important insurance policy. It tells you when your code is executing and you pass one of your variables as a parameter to another function, that function cannot change your variable. The original stays the same. The copy gets zeroed out, but the original stays the same. Watch what happens to the copy when display money is done. Obviously, when we hit the closing curly brace of display money, we're going to go back to here. But look at this right side. Look at the local variable and look what happens to that local variable when we return. Boom, the local variable disappears. The local variable that we zeroed out, well, who cares that we zeroed out? It's not the global variable. The global variable's just fine. I print money afterwards, and guess what? The original variable's not changed. It's still $20. The function that displays how much money we have shouldn't be changing the value of the money. And that's what pass by value means. This is very, very important. If every time I called this function I had to worry about my variable money, I'd have to constantly be checking it when I got back. So pass by value says make sure that the parameter is a copy of the variable I sent to the function. That way, any changes made in the function will not affect my original variable. Pass by value means $cash the parameter, is a copy of the variable passed to the function. There is no way the original variable, $money, can change no matter what I do to it in the function. Data types like int, float, and string are always passed by value. So if I have a variable that's containing a string and I pass it to a function, that variable will contain the same string when it gets back. There is another way to pass a parameter. It's called pass by reference. That's when the parameter is not a copy of the variable passed. That's when changes to the original will happen. Now, I'm not going to show it yet because we're not quite ready to study pass by reference. Objects are passed by reference. And when we get to objects, we'll talk about pass by reference. There's another way to make something pass by reference. If I go up here and put an ampersand in front of here, it says don't make a copy, use the original variable. But again, we're not quite ready to do that. For now, just keep in mind that ints, strings, floats, they're passed by value, it'll make a copy. When we get to the point in the lecture where we can suss pass by reference, we'll get to it. More on pass by reference when we cover objects. For now, by default, think of parameters as copies of the variables passed to the function, not the original variable. One more slide here to kind of wrap up functions, and we'll talk about globals versus parameters. What we're going to talk about here is we have options. Functions need input. Functions need output. But there's two different ways we can get data into and out of a function. One is to use global variables, and the other one is to use parameters and return values. When writing a function that needs input and output, we'll have option A. We'll use a parameter and a return value as input and output. Or option B, we could use a global variable. And the best way to illustrate when to use what is to go through examples that use both techniques. So we'll start with option A. $level is a global variable. Once again, our global variables should be the important information. Well, what level is the player on? Are they on the level 1 screen, the level 2 screen, the level 3 screen? We'll make $level a global variable and set it to the current level the player is on. At the start of the game, as you would expect, we're on level 1. Functions may need access to this information. Let's look at both different ways to provide that access. Option A, use a parameter as input to the method. Bump level is going to jump me to the next level. It's going to move me from level 1 to level 2. Let's send $level, the global variable, as a parameter to bump level. And as you can see, it made a copy. Parameters are copies. They're not the original variables. $lev has a copy of level. That one get copied down to this second variable. Got that? Lev is a completely different variable. Now I sent a copy. I'll change the value of the copy. Plus says add 1 to lev and store the result back in lev. So you can see over here on the right in the red box that local variable went to 2. Well, that's important information. We've just jumped from level 1 to level 2, but we did it in a copy. So we better return that copy back to the caller. Again, we're doing option A, and we'll send the return value 2 back as output from the method. So this is sending 2 back to the original caller. What does the original caller do with that 2? It assigns it to the global variable level. My global variable was 1 and was input to this called the bump level. It then sent back the output of 2, and bang, my global variable went to 2. Also notice what happened to my local variable? It disappears. That's what local variables do. They disappear when their function is done. Luckily, I took it and stored it in a global variable, so I still have access to it. Bump level, which is say advance me another level in the game, did its job. I gave it an input of 1, it gave me an output of 2, and I'm keeping track of my current level as being 2 in the game. That's what you've got to do when using parameters and return types. You have to pass the input as a parameter and use the output, the return value, to update the global variable. I don't always have to do it that way. There is another way to get information into and out of a function, and that is to use global variables, or option B. What we're going to do is use the current global value of 2 as an input. This is called a precondition. We're just going to call this second version of bump level. Notice there's no parameter here. Since we're using option B, we don't have to pass a parameter. What we're going to do inside the function is say use global level. Use that 2 as input to the function. Use the global variable as input to the function. If we use the global dollar level, it already has a 2 in it. We'll add a 1 to it. 2 plus 1 is 3. Again, we're using option B. Level was 2 before the method call. That 2 was input to this function. We'll assign the result of that math equation to the global variable level. We'll change it to a 3. Using option B, the global level is set to 3 after the call. It then becomes the output. It's a little tricky because you can't see it, but the 2 that was in the global variable was input to this version of bump level. The 3 that's in the global variable is now the output of this function bump level. When it function bump level returns, it will go past this call and continue on with the code. Before the call, the global level was 2. It was the input to this second version. After the call, the global level is 3. It is the output. So there you have it. When you're ready to call a function, you have two different ways to do it, to send it input. You have two different ways to get output. Again, your first option is use parameters and return values. I must stress that parameters and return value is considered a better programming practice. If I was given a choice of writing these two different versions of bump level, I'd pick option 1. Bump level is considered much more solid programming practice. Use parameters and return values whenever you can. Option number 2, global variables, again, we want to use those sparingly. Too many is too much. If I have 50 global variables, it is very hard to keep track of all of those. So we want to use global variables when needed, but we don't want to use them all the time. Third point I'll make is experience is the best teacher. When you've done it over and over and over again, and you start to see the advantages of parameters and return values, you'll know when to use them. You'll see when to use globals too. I basically do it, well, how often am I using it? How often am I doing it? Those very, very critical things that every function is going to need to deal with. X and Y position, health, score, level. Those belong in the global variables, and I should use those global variables. But again, experience is the best teacher. That wraps it up for functions. Good luck with the rest of your lessons. We'll see you on the next one.